else do we have here? The alcohol, color that green, right? That. Got 1H here. What we started doing, we started coloring the double bonds with these yellow-green, right? That way it was easy to see the double bond. So kind of throw that in there, double bonds, right? This here's done. Huh? Carbon there. So you know what will happen is you'll start wanting the rings to be more complicated because there's more color and stuff to it, you know? I mean, look at, that's just a 5-membered ring of tryptophan. So it really shows the double bonds, the N. Huh? And this down below is just a benzene ring. So any one of these, it isn't connected to anything, has to have an H on it. So there's 1, 2, 3, 4. So there's some double bonds in here, right? Color them. It gets confusing because some of these, I mean, the double bond looks like a diamond itself, right? So, color in the carbons, they're done, right? 1, 2, 3, 4 bonds, 4 bonds, 4 bonds. And I told you, down here, first reaction it's going to get down at the bottom here, it's going to get hydroxylated. Remember, ASE on the end of something makes it an enzyme, so it must be a hydroxylase. And all it's going to do is hydroxylate that first reaction here in this little progression that we're doing. What we're going to find is that's actually the active form. You're going to see it called 5-hydroxy. Tell you what, let's just draw a little arrow over here to save space. Draw a benzene ring. It's going to have right here. OH. So the first reaction is going to bring us to that. And best way to write that. It's going to be called a 5-hydroxy. Read that. 5-hydroxy tryptophan. There's one that's going to be a hydroxy tryptamine. That's another active form of one. So this is just the first thing that's going to happen is it's going to get hydroxylated there. Not all going to fit on the camera. So this simply is tryptophan. And then this is 5-hydroxy tryptophan. C, O, OH. That's amino acid backbone. So, now what's going to happen on the carboxylic acid up here going to have an enzyme that takes that away. CO2, you remember that? Diamond. Two O's, double bound, right? So here we're going to write, actually it should be from down here, huh? Call this reaction 2. We'll take away C2, CO2. To a 5-hydroxy Tryptophan, amine. This is serotonin. So much of your mood brain chemistry is relying on this. So see, you need tryptophan in your diet. You need the enzymes, 1 to hydroxylate it, 2 to decarboxylate it. That's going to make the 5-hydroxytryptamine. That's the active form of it. So again, to stay with our form here now, it's just simply this molecule here minus the CO2 and an OH on there. So we're going to draw it the way it shows it in the book. Or should we draw it? Should we keep our form going this way? Because see, we don't have a backbone anymore. And see, that's where it gets confusing, because now you got an NCC. Okay, we're going to keep it this way so you can see where it came from. So it's strictly a terminal N. To 2 carbons. And that 1 carbon there, remember, it's going to go down to the side. Got that in there. That way we can get the double bonds going this way. It's going to look exactly the same. Put that there, and then we'll get this big end to connect these two. So again, if you want to take a little break and color some in, that's fine. I'm going to color in the double bonds. There's that. Now, if you wanted to put the H's in, I mean, go to town. So even though you got 2 CH2 groups on there, you got to remember that 1 was this one. So see, you got 2 ends coming this way because that puppy's gone.